Okay, oops, here we go. Today we're going to be talking about angles of elevation and depression. Again, when I'm talking about elevation, I'm talking about an angle created by looking up from the horizontal. So I'm gonna imagine that I'm at the horizontal, and then if I'm looking up to make the angle, then that means that I have an angle of elevation. Angle of depression is angle created by looking down from the horizontal. So in this first problem, so I'm going to pretend that I'm this bird up here. Again, my horizontal here is right there, and if this angle 1 that I'm creating is from the horizontal, I'm looking down at this person down here. So this would be depression. For the second one, I'm imagining that I'm this dude in the hot air balloon. Again, my horizontal's right here, and I'm looking. So from my horizontal, I'm looking up at the bird, and so angle 2 would be an angle of elevation. Same thing for number 3. I'm still the guy in the hot air balloon. From the horizontal, I'm looking down, and so this would be an angle of depression. And then the last one, again, my horizontal's here. My angle's made coming up, so I'm pretending I'm an ant on this hill or whatever, and I'm looking up, so it would be elevation. Again, from the horizontal, am I looking up or looking down with the angle that's being created? So the second, this problem here, suppose you stand 53 feet from a wind farm turbine. Your angle of elevation to the hub of the turbine is 56.5 degrees. Your eye level is 5.5 feet above the ground. Approximately how tall is the turbine from the ground to its hub? And so what I want to do here is, again, I'm going to make a drawing of this. And so at the bottom, I'm going to draw me. And I'm going to be looking up at this wind turbine. Again, I'm 5.5 feet tall. Oops. To my eye level. So that's 5.5 feet. And then over here, I'll go ahead and draw my wind turbine. There's my hub. And then I have my blades, something looking like that. I'm not a very good drawer. There you go, something like that. And so again, from my eye level, I'm going to go ahead and make a line, go into the hub, then a line, whoops, straight down like that, and then connect the dots together. So this is my right triangle. It tells me that I'm 53 feet from the wind turbine. Again, we're always going to assume it's from the bottom, so 53 here. My angle is 56.5 degrees. And then this is what I want to try to find. So I want to try to find the height. So I would use the tangent of 56.5 is equal to x over 50, is it 53? Yep. And then I can multiply both sides by 53. Oops, 53. A little dyslexia there. So when I do that, these guys cancel out. Tangent of 56.5 times 53 gives me 80.1. And then remember, this is just the height here. And so what I have to take into consideration is that my eye level is 5.5 feet. And so this portion right here is 5.5 feet. And so I can add that to my 80.1 and get my final height of 85. Wow, again, 85.6 feet. So that would be my final answer of about how tall this wind turbine is. Here's another one. Again, I'm going to start in a plane, and I'm going to be looking down as I make my descent. And so first thing I'm going to do is draw a quick plane here. That's my cool little spaceship plane or whatever it is. And so again, this is my altitude. Here's my descent going down, and then here is right angle. There you go. And so again, it's saying that my descent is 3 degrees. Again, that's going to be an angle of depression, and that's always going to be 3 degrees from the parallel to the ground or from the horizontal. So I draw my horizontal, and so this is going to be 3 degrees. my height, it says, so my starting height is 2,714 feet, and the airport is 1,007 feet above sea level. So again, up at the top, I'm starting up here at 2,714, and then I'm going to end down here at 1,007. So I can do that in my calculator, 2,714 minus 1,007, and that gives me a height of 1,707 feet. Then it asks me how far from the runway is the plane at the start of the approach. And you can kind of take it both ways, either the hypotenuse or the bottom of my triangle here. We're actually going to just assume that it's talking about the bottom. And here's kind of the part that we get a little tricky, is this 3 degrees isn't part of my triangle. So I have to know that my vertical and my horizontal make a right angle. And so this angle right here is going to be 87 degrees. Another thing that I can know is that this 3 degrees, the horizontal right here and right here are parallel to each other. This is a transversal cutting them, and so then these are alternate interior angles here and here, and so this is going to be 3 degrees as well. And so then I can do it either way. I can use 87 or 3. So if I would use this 3 degrees over here, and so this would be opposite and adjacent, and so I can do the tangent of 3 is equal to 1707 divided by x. So I can multiply both sides by x. These guys cancel out, and so then divide both sides by the tangent of 3. So we get an answer of 32,571.5 feet. And again, it wanted that in miles, and so what I can do is I can set up a proportion. So 1 mile is 5,280 feet, and so I want to know how many miles are in 32,571.5 feet. And so I get, again, cross multiply and divide, I get 6.2 miles. Again, making sure that I'm using angle of depression here, and I also know that these are alternate interior angles, my 3 degrees here and my 3 degrees here. Find an angle that's in my right triangle. And then this is the last one. So I'm looking down a zip line that's 400 feet long diagonally and 30 feet high. What's the angle of my zip line? So I've got my height of my zip line. This is my actual zip line. And then there's my horizontal. So again, 400 feet here and 30 feet here. So again, what I want to talk about is, since I'm looking down a zip line, my zip line is going down, not up in the air, so this would be an angle of depression. And again, from the horizontal, I want to find out what that angle is. And so kind of the trick here is that I know that, just like we talked about in the last one, that this is going to be an alternate interior with this angle. And so if both these angles will be the same, so they'll both be x. So then I can set up my equation using the sine of x is equal to 30 over 400. And so I can do inverse sine of 30 over 400. And get that my angle of depression here is 4.3 degrees. So my zip line's 400 feet long and it goes down at an angle of 4.3 degrees. And there's the homework.